Welcome everyone. Today we are going to discuss one of the fundamental concepts of data communication networks, the modes of communication. There are three basic modes we need to understand: simplex, half duplex, and full duplex. In simple terms, simplex means one-way communication, and the half duplex is two-way communication, but one-side communication at a time. Full duplex means two-way communication, and both sides can communicate at the same time. Before we look at each one, let's understand what we mean by a communication mode. The communication mode describes how data flows between communicating devices. In simple terms, it answers three questions: who can send, when can they send, and can both sides send at the same time. So, this is one of the rule book. This rule book is followed by communication mode: sender, channel, and receiver. The next one is simplex. Let's start with simplex. Simplex means communication happens in one direction only. We have a sender and a receiver, and data flows only from the sender toward the receiver. For example, from sender to receiver, the receiver does not send back through the communication path. A real world example is a TV broadcast. The broadcaster sends the television program to your TV. So another example is FM radio. The radio station broadcasts the signal and your radio receives it. We can also use a keyboard as a simple conceptual example because we are using day by day. Keyboard to computer is a good example for simplex. So the key point is to remember is simplex is one-way communication. The next one is we move to half duplex. Half duplex is a different because communication happen in both directions. However, both the sides cannot transmit at the same time. They have to talk turns. A very easy example is a walkie-talkie. Person A speaks with while person B listens. Then person A stops and person B speaks. So the communication look like A to B and B to A, but not simultaneously. Why can't both transmit at the same time? Because they are sharing the same communication medium. Here you can see even though they looks different, so channel, it act as a single one. Okay. And simultaneous transmission can result in a collision. So remember that half duplex is two-way communication, but one side at a time. Next is full duplex. Now let's look at full duplex. Full duplex allows communication in both directions at the same time. A familiar example is a telephone call. I can speak with the other person speaking, and both sides can transmit and receive simultaneously. In networking, modern picture Ethernet commonly operates in full duplex mode. This means a device can transmit and receive simultaneously. So, simplex is one way, half duplex um, is two ways talk turns, full duplex two ways simultaneously. This is a little bit comparison table between simplex, half duplex, and full duplex. Okay, now connect it to the real networking. This is actually the strongest part of your video in this video. Now you may be thinking, why do I need to learn this in a networking course? Because these concepts appear directly in real networking environments. Let's take the example of a hub. A traditional Ethernet hub operates in a shared hub duplex environment. Multiple devices share the same communication medium. If two devices transmit at the same time, the signals can collide. occurs. That's why Ethernet historically used mechanisms such as CSMA CD for shared hard Bublox networks. Now compare that with a switch. A switch provides a separate collision domain, a port, and modern switched Ethernet normally operates in full duplex mode. In full duplex Ethernet, collisions do not occur because the device can transmit and receive simultaneously over the link. That is much more technically solid. Switches was developed to remove collision. So I have taken a GNS3 example for to explain this one. Now let's move from the theory to real networking environment. I have connected two routers in my lab with a switch. So we can observe the differences between half duplex and full duplex. On the interface, I have configured this interface configured with half duplex. When I use the appropriate command, we can see the interface duplex settings. Here, the interface is operating in half duplex mode. Now let's here you can see that. So this is the full duplex mode. So this is the two differences between half duplex and full duplex. So I have configured both in a real-time environment to define how it works in our real-time networks. So this is where theory becomes practical. We are not just memorizing the definitions of simplex, half duplex and full duplex. We can actually see the configuration on a networking device. Now let's understand the Ethernet speed shown in our lab. Ethernet traditionally refers to 10 Mbps Ethernet. Here, fast Ethernet. Okay, this is the fast Ethernet. It means it's supposed to 100 Mbps. And the gigabit Ethernet operates on Gbps, which is equal to 1000 Mbps. Okay, so remember, 10 Mbps explain result Ethernet. Sorry, 10 Mbps defines Ethernet. 100 Mbps defines fast Ethernet. 1000 Mbps defines or 1 Gbps defines gigabit Ethernet. And one important point, speed and duplex are two different concepts. Speed tells us how fast data can be transmitted. Duplex tells us how communication happens between the two ends. So don't confuse 100 Mbps or 1 Gbps with half duplex and full duplex. I have given this example for your clarification only. Okay, now let's you understanding how to test it now. Question A, is the keyboard simplex or half duplex? The answer is simplex because the communication is considered to flow from keyboard toward the computer. So there is no written path or written communication path through the same conceptual communication path. Question number two. The two pieces are connected to the hub. Okay. If both transmit at the same time, we can can happen? The collision occurs because the hub creates a shared hub duplex communication environment. The question number three. So now you understand hub duplex and simplex. Suppose one side of Ethernet link is configured for full duplex and the other side is operating at half duplex. Simply, you set full. The ping is very slow. So what happened? This is called the full duplex mismatch. It can result in a poor network performance, errors, and retransmissions. Therefore, the two ends of your Ethernet link need compatible speed and duplex settings. So when you work in a real-time environment, when you configured Cisco devices, you can understand this well. Okay, so Let's summarize everything we learned today. Simplex one-way communication, hub duplex two-way communication, but one side at a time. Two-way and full duplex two-way communication at the same time. We also connected this concept to real networking technologies such as hubs, switches, Ethernet, fast Ethernet, gigabyte Ethernet, and most importantly, we saw how this concept can be observed in a practical networking lab. Understand these fundamentals will make the advanced networking topics much easier to understand in future studies. Thanks for watching, and I will see you in my next lesson.